Three other anions that act as bases, that is, as proton acceptors, are the sulfide ion, S2-, the carbonate ion, CO3 2-, and the bicarbonate ion, HCO3-. All react with acids to form gases. For example, the sulfide ion reacts with acids to form hydrogen sulfide gas. You can see in this equation we have hydrochloric acid, which is a strong acid, reacting with a sulfide compound, potassium sulfide, and what we're going to get is hydrogen sulfide gas and what's left in the equation but potassium and chloride. Now we need to balance this equation. We have two hydrogens on the right and only one on the left, so there's the balanced equation. Notice that we have the sulfide ion acting as a base, accepting protons. If we were to write the net ionic equation for this reaction, we know that hydrochloric acid is a strong acid, and the potassium ion in potassium sulfide will definitely make this compound be a strong electrolyte, so it will exist in solution as ions. Let's look on the right side. Here we have the potassium ion and the chloride ion. Those will be separate from each other. They will float around separately in aqueous solution. So I think what we need is we need some hydrogen ions on the reactant side, we need a sulfide ion on the reactant side, and then we need this neutral H2S gas on the product side. Let's try another example or two. How about the carbonate and the bicarbonate ions? These react with acids, that is, they act kind of like bases, and form carbon dioxide gas. In this reaction, we have nitric acid reacting with calcium carbonate to form, sure enough, carbon dioxide gas and also water and calcium nitrate. If we balance this, we'll put a 2 out front of the nitric acid and we'll be good to go. If we take another acid, hydrochloric acid, and react it with sodium bicarbonate, better known as baking soda, you can see that again, whenever we acidify a carbonate or a bicarbonate, we're always going to get carbon dioxide and water, actually. You may have done this experiment or seen this demonstration taking sodium bicarbonate, baking soda, and acidifying it, typically with vinegar, and you get this volcano effect. Let's summarize this lesson. Other anions acting as bases. 1. The first anion we must know that tends to act as a base, that is, a proton or an H+ acceptor, is the hydroxide ion OH-. When OH- acts as a base and accepts a proton, water is produced. 2. 3 other common anions that act as bases, and the key product produced when accepting H+ are the sulfide ion, S2-, the key product produced is H2S gas. The carbonate ion, CO3 2-, the key product is carbon dioxide gas. And with the bicarbonate ion, HCO3-, the key product is carbon dioxide gas.